'76 Chevy racked up 420,000 miles and kept hauling, passed down to the next generation. Meanwhile, a brand new 2021 truck broke down before hitting 70,000. So, what happened? Today, we're diving into the vintage pickups that were built to last a lifetime, and the surprising engineering choices that made them unstoppable. Let us know in the comments if you ever owned one of these babies. The Dodge D-Series wasn't flashy. But with the legendary 225 Slant Six under the hood, it became one of the most reliable workhorses ever made. Nicknamed the Leaning Tower of Power, this engine was mounted at a 30-degree angle, but what really made it famous was its ability to run forever. The engine's distinctive tilt wasn't just a quirky design choice, it offered real packaging benefits, allowing for a sleeker hood profile which improved visibility and made servicing easier. More importantly, it contributed to improved oil distribution to the valve train, keeping things lubricated even under the most demanding conditions. This clever design, combined with the engine's robust construction, played a huge role in its legendary durability. Farmers, contractors, and small businesses loved these trucks because they simply refused to die. The Slant Six could take abuse like few engines ever built, running on questionable fuel, tolerating skipped oil changes, and surviving extreme weather without complaint. One of the reasons it earned a cult following was its simplicity. With just a single-barrel carb, no electronic components, and bulletproof internals, mechanics could keep these trucks running with basic tools and parts from any auto store. And while the engine became legendary in taxis and sedans, it was in the D-Series pickups where its durability truly shined. Some racked up over 300,000 miles before a major rebuild. Ford's 7.3-liter IDI Diesel brought industrial-grade reliability to pickup trucks before electronic complexity took over. This international harvester-designed engine proved that American manufacturers could build bulletproof diesels when they prioritized durability over sophistication. The 7.3-liter IDI used indirect injection, where fuel was sprayed into pre-combustion chambers before entering the main cylinders. This system operated at lower pressures than direct injection, reducing stress on fuel system components and improving long-term reliability. The engine displaced 444 cubic inches with a bore of 4.11 inches and stroke of 4.18 inches. Naturally aspirated versions typically produced around 170 horsepower and 315 pound-feet of torque, while factory turbocharged variants introduced later increased output to 185 to 190 horsepower and 360 to 390 pound-feet. The conservative power ratings contributed to exceptional longevity. The rotary injection pump was mechanically driven, requiring no electronic controls in early versions. This simplicity meant the fuel system could be serviced by any diesel mechanic with basic tools, making repairs possible anywhere in the world. Commercial fleets discovered these engines could accumulate 400,000 miles with routine maintenance. The engine's tolerance for heavy loads and continuous operation made it popular with contractors who needed reliable work trucks that wouldn't leave them stranded on job sites. The Dodge Power Wagon brought military-grade engineering to civilian pickup trucks. Built using components proven in World War II service, this truck combined battlefield-tested reliability with mechanical simplicity that made it virtually unstoppable. The 230 cubic inch Flathead 6 was designed to run on whatever fuel was available in combat zones. The engine's extremely low 6.7-to-1 compression ratio allowed it to operate reliably on low-octane gasoline or even kerosene when necessary. This flexibility made it ideal for remote applications where fuel quality was questionable. The engine produced 94 horsepower at 3,200 RPM and 185 pound-feet of torque at 1,200 RPM. While these numbers seem modest, the engine was designed for continuous operation under extreme conditions rather than peak performance. The Flathead design placed valves in the block rather than the head, creating fewer failure points. The Power Wagon's four-wheel drive system was equally robust, using components designed for military vehicles that needed to operate in combat conditions. The transfer case, axles, and drivetrain were all overbuilt for civilian applications, creating a truck that could handle abuse that would destroy conventional pickups. Fire departments and utility companies kept Power Wagons in service for decades because they would start and run in conditions that stopped other vehicles. Many accumulated hundreds of thousands of miles over 30 to 40 years of continuous service. Ford's 239 cubic inch Flathead V8 represents the pinnacle of flathead engine development. By 1948, Ford had refined this design through 16 years of continuous improvement, creating an engine that combined adequate power with legendary reliability. The Flathead design placed all valves in the engine block rather than the cylinder head, creating a power plant that was mechanically simple and virtually indestructible. While this limited power output, it eliminated many potential failure points that plagued overhead valve engines. The 239 featured a bore of 3.1875 inches and stroke of 3.75 inches, producing 100 horsepower at 3,600 RPM and 180 pound-foot of torque at 2,000 RPM. The engine used three main bearings supporting a forged steel crankshaft, while the cooling system was deliberately oversized to handle extreme operating conditions. The fuel system consisted of a single-barrel carburetor and mechanical fuel pump, components so simple they rarely failed in service. When problems did occur, repairs could be completed by any mechanic with basic tools and readily available parts. Ranchers and farmers discovered that 239-powered trucks could handle continuous, heavy-duty use that would destroy more sophisticated engines. The engine's tolerance for poor fuel quality and irregular maintenance made it ideal for remote applications where service facilities weren't available. The International Harvester Scout earned recognition through International's approach to building vehicles like agricultural equipment, robust, simple, and designed for decades of hard use. The Scout's various engines shared this philosophy, but the 152 four-cylinder stands out for its exceptional durability. International designed the 152 specifically for severe-duty applications. The engine displaced 152 cubic inches with a bore of 3.5625 inches and stroke of 3.656 inches. The engine produced 93 horsepower, a respectable output for its size and era, and was built to handle continuous operation under load. The cast iron block featured deep skirts and heavy webbing that could withstand the stress of off-road use and heavy hauling. The cylinder head was also cast iron, creating a combustion chamber that could handle extreme temperatures without cracking or warping. What made the 152 special was its ability to continue operating when other engines would fail. The simple mechanical systems could be repaired at any typical garage, while the robust construction meant these engines could handle abuse that would destroy more sophisticated power plants. Scout owners discovered that 152 engines would run for hundreds of thousands of miles with minimal maintenance. The engine's tolerance for neglect made it popular with rural users who needed reliable transportation in areas where dealer service wasn't available. The Ford 300 cubic inch straight six stands as proof that conservative engineering often creates the most reliable results. While Ford promoted flashy V8s, the humble 300 quietly became one of the most indestructible engines ever installed in a pickup truck. The 300 featured a bore of 4 inches and stroke of 3.98 inches, typically producing between 110 to 140 net horsepower, and 220 to 250 pound-feet of torque. Depending on the year and specific configuration. 7 main bearings supported a forged steel crankshaft that was sized for engines producing twice the power, creating massive durability margins. The engine's long-stroke design created exceptional torque at low RPM, perfect for truck applications where pulling power mattered more than high RPM performance. The conservative power output meant internal components operated well below their stress limits, contributing to exceptional longevity. UPS fleets notably utilized the 300, where its robust design allowed delivery trucks to accumulate hundreds of thousands of miles with diligent maintenance. Its reliability in demanding stop-and-go conditions made it a favorite for commercial applications. Tree service companies provided the ultimate test when they used F-250s to power wood chippers through PTO systems. These engines ran at full throttle under maximum load for 8 hours daily, with many accumulating over 15,000 operating hours before requiring major work. Toyota's 22R proved that Japanese engineering could create pickup truck engines with legendary durability. This 2.4-liter four-cylinder became famous for running indefinitely with basic maintenance, earning a reputation that continues influencing truck buyers today. The 22R displaced 144.4 cubic inches with a bore of 3.62 inches and stroke of 3.50 inches. The 22R engine, in its carbureted form, typically produced around 97 to 105 horsepower. While the later fuel-injected 22RE variant generally offered between 112 to 116 horsepower, with torque figures around 135 to 140 pound-feet. While these numbers seem modest, the engine was built for durability, not power in mind. The cast-iron block featured 5 main bearings supporting a forged steel crankshaft, while the aluminum cylinder head used a simple 2-valve per cylinder design that prioritized reliability over maximum airflow. The timing chain, rather than a belt, eliminated one of the most common failure points in modern engines. What separated the 22R from competitors was its ability to continue running even when severely worn. The engine would consume oil, make noise, and lose power. But it would still start every morning and provide reliable transportation. This tolerance for wear made it ideal for users who needed dependable trucks more than perfect performance. International markets proved the 22R's legendary status when Toyota pickups became the vehicle of choice in countries where mechanical failure meant economic disaster. These trucks accumulated hundreds of thousands of miles in harsh conditions, with minimal maintenance beyond oil changes. The Chevrolet 250 represents the ultimate evolution of GM's stovebolt engine family. By the late 1960s, this power plant had been refined through decades of development into one of the most reliable engines ever installed in an American pickup truck. The 250, initially rated using gross horsepower figures, could produce up to 150 horsepower and 235 pound-feet of torque. However, by the early 1970s, as net horsepower ratings became standard, figures typically ranged from 100 to 110 horsepower. Seven main bearings supported a forged steel crankshaft, creating a bottom end that could handle continuous operation under load. The engine's hydraulic lifter valve train required minimal adjustment, while the simple rocker arm arrangement was virtually maintenance-free. The timing chain eliminated belt replacement intervals, while the gear-driven oil pump ensured consistent lubrication throughout the engine's operating range. Fleet operators discovered the 250's exceptional reliability in commercial applications. Delivery companies and utility fleets relied on these engines because they provided consistent transportation with minimal maintenance requirements. Many accumulated over 300,000 miles before requiring major engine work. The fuel system's simplicity contributed significantly to reliability. The single-barrel carburetor was virtually foolproof, while the mechanical fuel pump rarely failed in service. When problems occurred, repairs were straightforward and inexpensive using readily available parts. The Cummins 5.9-liter 12-valve diesel transformed the pickup truck market when Dodge introduced it in 1989. This industrial-grade power plant brought heavy-duty reliability to consumer trucks, creating a legend that continues influencing diesel truck buyers today. The 5.9-liter displaced 359 cubic inches with a bore of 4.02 inches and stroke of 4.72 inches. The engine produced 160 horsepower at 2,500 RPM and 400 pound-feet of torque at 1,700 RPM in early versions, with later models increasing to 175 horsepower and 420 pound-feet of torque. The engine's rugged cast-iron block and head formed a rock-solid foundation built to endure the extreme pressures of diesel combustion. Designed with continuous, heavy-duty use in mind, it handled towing, hauling, and long idle times without breaking a sweat. The 12-valve's purely mechanical design was its greatest asset. The rotary injection pump was gear-driven from timing gears with no electronic controls or sensors to fail. Any diesel mechanic could service the fuel system, making repairs possible anywhere in the world. Conservative power ratings contributed to exceptional longevity. The engine was designed to handle much higher power levels than its factory rating, meaning internal components operated well below their stress limits. This approach allowed many engines to accumulate 400 to 500,000 miles with routine maintenance. The Chevrolet 350 cubic inch small block V8 earns the top spot through sheer ubiquity and proven durability. This power plant combined adequate power with exceptional reliability, making it the backbone of American pickup trucks for over a decade. The 350 featured a bore of 4 inches and stroke of 3.48 inches, typically producing between 130 to 155 net horsepower depending on the year, emissions equipment, and specific configuration. The cast-iron block used 5 main bearings supporting a forged steel crankshaft, while cast-iron cylinder heads created robust combustion chambers. The engine's design emphasized simplicity and serviceability. Hydraulic lifters required minimal adjustment, while the simple rocker arm arrangement was virtually maintenance-free. The timing chain eliminated potential belt failures, while the gear-driven oil pump ensured consistent lubrication. What made the 350 legendary was its tolerance for abuse and neglect. Fleet operators discovered these engines would continue running even when maintenance was delayed or operating conditions were severe. The robust construction and conservative power output created durability margins that allowed survival of treatment that would destroy more highly stressed engines. Commercial applications proved the 350's durability across multiple industries: utility companies, construction firms, and government fleets relied on 350-powered trucks because they provided consistent performance with reasonable maintenance requirements. Many accumulated over 200,000 miles before requiring major engine work, impressive longevity for gasoline engines of that era.